have seen hockey games and figure skaters on TV, but it's usually a mystery as far as what the ice is and what's underneath the ice. Unbeknown to an awful lot of people, the ice is only about an inch to an inch and a half thick. There's about 15,000 gallons of water that's frozen perpetually, and the piping system that does that is what we're going to show you is being manufactured here today. The piping system consists of literally 26 miles of tubing that's contained underneath the ice sheet for heat transfer. It's 22,000 square feet of surface area, and it's designed to maintain the ice sheet between 15 and 20 degrees. In making up the piping system, we're using a extruded spacer strip to make up what we call our porta-pipe and our perma-pipe Rink piping systems. These are both for permanent and for portable applications for the ice shows. And this is a flexible material that's extruded and then punched into a uniform T configuration. We get the strips 4 feet long. And we use these as the basis to make up a prefabricated mat, so we don't have to also field apply each individual tube in the rink floor. When we get to a rink site, we take these mats that are prefabricated, literally roll them out, and install them, and there's very little field fabrication work. Here you can see the table where we mark a table and put the spacer strips down at specific intervals. And then with those intervals, we go ahead and commence and put the tubing in. And go ahead and pull that out. The materials that we use are polyethylene, and the reason we use polyethylene is good for heat transfer performance. It's relatively an economical product, and also it doesn't become brittle until about 104 degrees below 0 Fahrenheit. The importance of that is we wouldn't want a plastic that's brittle at the temperatures that we use for an ice rink application, which is, again, that 15 to 20 degrees. Otherwise, we'd have plastic breaking and things of that nature. You can look at a piping system like this, and you can see how the tubes are pulled off of long spools. They're about 2,000 feet long spools, and then they're snapped into position. And the fellow will be coming up here and show you how they snap right into place. The half-inch tubes are located every inch and a half on center across the whole mat to make up the 32-tube wide mat. The system's designed to run with a working pressure of about 15 to 20 psi, and that's about all. So it's a more high-volume flow rate system than it is a working pressure system. Sometimes people think, well, what happens if my piping system gets a leak in it? And like any piping system we have some kid with the heel of a skate decide that he wants to test the ice to see if there's fish underneath in the pond, and they chip through the ice sheet and hit one of these tubes and create a leak. What they'll do is they would leak out some ethylene glycol, and we simply get to that location, wherever the leak would be, you chip through the ice and cut the tube right where the leak is and put a splice bar in. It's a very easy repair. It takes about 15 minutes, and it's really a $5 5-minute repair. And that's the assembly. It's a very simple, fast-to-produce system. After they're all assembled in a full tube, we commence to trim the ends, and we put a U-bend in on the end, and we'll show you those over here. Here's the mats fully fabricated. Now you can see how the U-bends come around here on an angle, and what that means is this is a radius mat. This is one of the mats where the tubes go right up into the corner, and we factory fabricate these to match the radius before they go into the field. Again, so there is no field fabrication required. The process of putting a U-bend in is pretty simple. We use a 17/32 OD hard copper U-bend that's made for us, and we insert it, and then we clamp it with 2 stainless steel pinch clamps, and it makes up the finished product. They're pressure tested, and they're ready to go, and they ship out in spools just like this, and they ship all over the world. We can show you down at this end how the process of putting the U-bends in take place. We've used these type of mats for everything from ice rinks to speed skating tracks. We've even quoted some projects for luge runs where they want to run bobsleds and have it refrigerated so they don't have to depend on Mother Nature to do that. Down here on this end is where they go ahead and install the U-bends. Do you have a U-bend handy? We use a tube cutter as opposed to taking a typical razor blade, and this makes it real easy to cut the tubes directly to the length that we need. All of the plastic that we cut, and we do have an awful lot of scrap plastic that we make from the piping and also from the dashboard applications, and that's all recycled. Okay, you have a U-bend handy? The complex aspect of these products is the design of them beforehand and knowing what type of materials to use and what type of center-to-center ratios they have to be on, things of that nature. The actual manufacturing process is quite simple. So even a guy who talks on the video can put these things together. That's basically the process. And then we have a pinch clamp that we move up here and we pinch, which I don't have a tool handy to demonstrate that, but that's a simple stainless steel pinch clamp. And that's the process, which is quite simple. We'll go up to the rink now and show you what the finished product all is about and how it goes in, and a little bit more details of a running refrigeration system. Now that you've seen all the components that are manufactured in our factory, you'll see how all those components are assembled together to work as a unit for the finished product. Here we are in Planet Ice, the Arena Training and Technology Institute, and you can see here with the products, everything that you saw in subcomponent form is installed in the ice rink application. Here's our batter boards. Here's the aluminum extrusions that you saw. Here's the frames, the hardware, in a fully assembled unit. Individually, they don't look like anything until they're put together into their finished form. On the ice sheet itself, all the rink piping systems that you've seen are contained underneath the ice sheet here. And you can say, well, those pipes weren't white, those pipes weren't orange, and didn't have red lines on them. How did that happen? And that's a process that we call a vice painting. After the piping's put down on top, there's a layer of sand that's put over the piping. After that sand's leveled and compacted over the piping system, it's totally saturated with a fire hose with water, so it's totally wet and almost puddles formed in it. We turn the refrigeration system on, and that 15,000 gallons approximately of water that makes up a full-size ice sheet is frozen into its frozen form. After that sand's frozen, it's very hard, almost like concrete, and we use that as the base to build the ice sheet atop of. We'll put another few floods on top of the sand until we get a permanent glazing, so it doesn't even look like sand so much, but there's a permanent ice sheet over the sand. And at that point, we paint the ice sheet. And painting the ice sheet involves mixing up white paint in a 55-gallon drum and spraying it down with a spray nozzle. And the paint doesn't really dry into place, it really freezes into place. It's almost like spraying milk down, and that's what gives it its real nice white sheet. And before that, it would just look like a big brown sand area before we painted it. And then you have areas like the lines that you see, and those lines are put down after the painting's all done. And after the painting process, we put a couple what we call seal coats down over the painting, and we proceed with the lines. The lines are done several different ways. Those can also be painted down with paint, but another popular way is to use tissue paper. They're rolled 20-pound tissue paper that's wetted and put down with hot water and rollers, just like a regular paint would be. And that's what makes up our red and blue lines. Now we're going to go back into the back mechanical room area and show you what really is the muscle behind the freezing process. Looks like fun. More fun than making them is using them. Open up the dump tank. Okay. This piece of equipment doesn't need much introduction. Everybody knows what a Zamboni is. Probably the biggest request we have in this facility when people come and tour the complex is they want to take a ride on the Zamboni. Not only that, but the Zamboni drivers are the most popular among the women for dates, I hear. The snow pit grid that we talked about earlier, the copper piped device that we were talking about, is down at the bottom of the pit. You can see the steam coming up, and that's where that grid creates the heat to melt the snow. Now, he recently dumped the snow. That's why we didn't have a pile of snow to dump in there. But all that snow gets melted and goes off to the drain. The heart of the ice rink is back here with the refrigeration system itself. Here we have a halocarbon, or what we call an R22 refrigeration system. It works under the exact same process as your home refrigerator, only on a much, much bigger scale. In this particular package of our turbo chiller, we manufacture all the complete electrical panels, and I'll show you what they're all about. Inside here, it's probably one of the most advanced electronical chillers that are made today. We use a complete microprocessor control system that runs the whole system. And what this enables us to do is we can call up, diagnose, and totally operate our refrigeration systems that we install any place in the world. We can have a person from Korea contact us and tell us he has a problem, and we can deal with it. And that was some of the motivation behind developing a microprocessor system as well. We'd do an installation in Korea, for example, and we'd have some fellow call us up and say, chiller broke, not work. And we'd say, well, what's the problem? And we'd get back, chiller broke, not work. And that'd be the most we'd get in information. And now, instead of having to run around trying to find our interpreter to translate what the problem may be, we can just call the unit up right from our homes or from our corporate office and totally diagnose what the problem is and tell them how to correct it. Another neat feature about this system, with energy efficiency being such an important prerequisite behind an ice rink operation, is the turbo chiller panels that we build also incorporate a kW meter where the main electric comes in. And the importance behind this is we can monitor the energy efficiencies of the unit at any particular time. We're the only company that does that. No other refrigeration company provides that type of monitoring equipment on their own system, and it's because the energy efficiency technology that we offer does produce a very low cost of operation. It's something we're proud of, where maybe the other people may not be so proud of. The pump skids that you saw downtown being made are here installed, and here you can see how the skid is incorporated into the overall piping practice. The refrigeration system, the pump skid, everything is factory fabricated. When it comes to the site, the amount of interconnecting piping that's required is very minimum. We try to look at service being a big factor to make sure it's easily serviced. Little things, for example, like the pressure transducers for the microprocessor control system. If something goes bad or is a problem, they can simply unscrew it like this and put a new one in. We have a valve right into the refrigerant system, so they don't have to worry about having any type of refrigerant leak. The refrigerant that we're using is a safe refrigerant. It's not one of the bad refrigerants that is a CFC. We're using an HCFC refrigerant. We are incorporating 4 50 horsepower compressors and the 4 pumps on the pump stat system as well. Up atop here, those 2 little devices up in the ceiling, those are heat exchangers that takes waste heat from the refrigeration system and use that heat for the subsoil heating system that I described earlier to keep the floor from heaving from frost problems underneath. So we regenerate and use the heat that we produce from the refrigeration cycle itself. All the heat we extract out of the floor, and you'd think there's ice, there isn't heat there, but we are actually extracting heat from it to keep it frozen. And then we use that heat for other purposes within the facility. Over here is the computer system. And this allows somebody who isn't very knowledgeable in refrigeration, which an awful lot of our customers aren't. The customer that we deal with are people who are not industrial engineers by any stretch of the imagination. They're not production managers. They're ice rink people, and we want them to be more concerned with getting people in the door than anything else. And this enables us, and this very much empowers the operator for the refrigeration system. This is a system that we have exclusively designed for us, and it's very intuitive from a computer-based system for running the refrigeration system. If the fellow's even at his own home, he can go ahead and contact the refrigeration system up and run it from his house if he'd like to. Outside, let me take a peek out here just a minute. We have a very extensive refrigeration, or a dehumidification system rather, that maintains the ice sheet humidity level. Outside the mechanical room, we have an evaporative condenser. We think all the heat that we extract from the floor that we can't use for other heat reclaim applications, what do we do with that? And that heat comes out here to our evaporative condenser. And the evaporative condenser is a process of air and water that converts the refrigerant back into a cycle that we can reuse for cooling. And basically the whole process of the refrigeration system is a physical change of the refrigerant, changing it from a liquid to a gas and then compressing it back to a high pressure gas, cooling it, and it comes back to a liquid. This is also another skid that we manufacture as a company. These are our LPA pumps and our receiver skid. And this is the field piping work that's done in the field. Everything else is skid mounted. Then we also have, shown over here, is a dehumidification system, which is very important for an ice rink, which is also manufactured by our company. And the dehumidification is designed to keep the